You have about 2 minutes. Number 1. Number 2, you did the first equation, so you could receive 0 credit. So these two are standard. Standard pressure. Standard temperature. Do that 30 seconds. Pause what you're doing, put your pencils down for a minute and just pass it here so I can make a brief announcement. I'm going to give you another minute. Alright. There's a lot of like aha moments that just happened in the last 10 minutes. There was like several people that were like, oh, I get it now. Okay. I want to give you 2 more minutes only because I see a lot of people like ignoring 5 and 7. And you're just like, I'm not going to do this because I know she's going to go over it and that's not okay. Because that's not going to help you. So I'm giving you 2 minutes. If you've answered number 7 but skipped number 5, I want you to go back and show work. If you haven't done number 7, I want you specifically to do that one, number 7. If you've already done 7, then I want you to do number 5. I'm giving you exactly 2 minutes and I expect that at least one of those problems is done with your 4 steps, given unknown equation answer. If I don't see it, you're not getting credit for it. 2 minutes right now. You're good. Keep going. From the videos. Repeat the videos that we watched, repeat videos. Okay. How did you see this relationship? Okay, if you're helping someone, that's fine, but I'm hearing too much chatter that would indicate that you're instead having a conversation. So let's get back to lecture hall. Finish 5 and 7, or 5 or 7. Okay. We're going to take about the next 12 minutes to go through this before you're going to have the time to do your review quiz over. So all we have is 12 minutes. We got to make sure we get this done. We're going to start from the top and work our way down. So first thing that's super important is what unit are you using when you're working with gas problems? Because I had this question a lot yesterday. Yesenia?
Kelvin.
Kelvin. So how would you convert, if you were given Celsius, how would you convert that to Kelvin? What do you need to do?
Add to -73.
You have to add to a -73 to equal your Kelvin. This is found in your reference table, so it's not essential that you memorize it, but it's essential that you know where to find it, okay? We're going to spend a little bit of time on the relationship between pressure, volume, and temperature. So first of all, your temperature and pressure, what is the relationship between temperature and pressure? Well, it's a direct relationship. Can someone give me, we watched like a variety of videos, right, to show the relationship. Which video showed the relationship between temperature and pressure? Don't just say peeps. Tell me which one we saw. Just Yesenia? Gilberto, what video did we see that showed the relationship between temperature and pressure? No. That's pressure and volume. Which one? You raise your hand? No. Diana? No? No, you didn't. You saw two different videos that day. Anymore.
We saw the one with the microwave and the one with the vacuum.
So which one showed the relationship between changing the temperature? The one with the microwave. When you heated the peep up, right? When you saw the peep that was heated, what happened to the pressure inside of the peep? Increase or decrease when you increase the temperature? Avalon.
When you increase the temperature, increase it.
The pressure also increased, okay? You saw it get a lot larger. What's your equation that you would use? You have only one equation, right? P1, V1, T1, P2, V2, T2. What equation would you use if you were only solving for temperature and pressure? Omar. Go, Alan. Yeah. P1 over T1 equals P2, T2. You're just getting rid of the volume. You're not using that part. What about for temperature and volume? What relationship do you have for temperature and volume? Diana?
It's a direct relationship.
It's also a direct relationship. This would be the exact same example when you heated the peep, okay? Because remember that temperature, pressure, and volume are all linear, okay? They have a linear relationship, so when one increases, the other one will, okay? What's your equation for temperature and volume? If you were to take out pressure, go, Erica. Yep. Good. And then the last one. This is the one that you need to remember. This is the only one that's opposite. So what's your relationship between pressure and volume, Erica? It's an indirect relationship. When one goes up, one's going to go down. And what video did you see when you saw this happen with your indirect relationship? Marnie? Okay, when you put it in a vacuum, can you explain briefly what happened?
With the peep in the vacuum, you decrease the pressure and the size of the peep increase.
So the pressure decreased in the vacuum by removing the air, and the volume, the peep actually got much, much larger, okay? So you gotta keep that as an example. What equation would you use if you were taking out the temperature part? Go.
P1 times P1, P2 times P2.
Perfect. Are there any questions with this one? There was a question on your test that asked this. If this is an indirect relationship, and one of these things increased, okay, and it doubled. So let's say your pressure doubled. If it's indirect, what would happen to the volume? If your pressure doubles, what's the indirect relationship that would happen to the volume? Go, Jamar.
It will be, half.
It's gonna be half. It's an indirect relationship, so it's exactly almost the opposite of what happens. We need to keep that in mind because that was a tricky question for you. We're not gonna go over this because this was straight from your notes, so you should have filled that in pretty quickly. We are gonna do this one, okay? What's gonna make a gas act like an ideal gas? We only have a few examples of ideal gases, okay, only 2. But what would make any gas act like an ideal gas? Gilberto. High temperature and low pressure. So, given an example, okay, you would be looking for the answer for the highest temperature and the lowest pressure given. So when you're given multiple choice, what strategy would you use, what test strategy would you use to pick out this correct answer? There's only one test strategy for that. What would be the strategy you're going to want to use? Give you a hint, it has to deal with your answers. Go, say it, Melanie. Elimination. So you're going through each one, clicking off which one can't have the highest temperature and the lowest pressure. Okay, we're going to go through 4, 5, 6, and 7. Should have shown your work for this. So give me what your given numbers were. Alan, go.
Pressure 1 was 2.5, volume 1 was 900, temperature 2 was 336.
Hold on 1 second. Pressure 2 was what?
Temperature 2 was 336.
What was your, oh,
It's higher than
what was your T1? What was your temperature 1?
298.
Good. What was your P2?
X.
This is what you were solving for?
And it was 450.
450. So you already know what you're solving for. You know what you're given. Guys, a lot of you are skipping this. If you had done this, a lot of people keep asking me, what equation do I use? I have 4 equations. I don't know which one to use. That makes it very simple because you know what variables you have. There's only one equation that fits this, and that's the P1